For centuries, history told us Polynesians and Native Americans never met before Columbus. But in 2020, DNA analysis shattered that belief. Genetic proof shows mixing around 1200 AD, someone crossed 4,000 miles of Pacific Ocean and left descendants that still carry the evidence. The catch? Science confirms contact, but nobody can say who sailed where or how the journey happened. The facts solved one mystery and opened an even deeper one. In 2020, Alexander Ioannidis and his team began a surprising question. Did the genes of Native Americans and Polynesians mix before Europeans arrived? The study gathered DNA from 807 people. They sampled 17 islands across Polynesia and 15 groups along the Pacific coast. Every participant gave consent, knowing their ancestry might unlock a hidden chapter of human history. The team used a technique called identical by descent analysis. It looks for long-matching DNA stretches that indicate shared ancestors. Random chance cannot produce such long identical segments. In the Polynesian samples, they found unmistakable segments of Native American DNA. These weren't short broken traces left by recent mixing. They were long intact stretches, evidence of a single ancient event. The segments traced back to the Zainu people of Colombia's Caribbean and Pacific edges. Researchers measured DNA length to date the mixing event. Longer segments mean more recent ancestors. Statistical models place the event around 1200 AD. The earliest signal appears on Fatu Hiva in the South Marquesas. That island lies over 4,000 miles from Colombia. The DNA pattern later spread to other islands over centuries. It was not a product of colonial times or post-Columbus trade. It was proof of contact centuries earlier, clear scientific evidence that rewrote the world's boundaries. Fatu Hiva sits deep in the South Marquesas, surrounded by thousands of miles of open Pacific. That's where the first trace of Native American DNA appeared, not on Easter Island, the closest Polynesian landfall to South America, but on an island even farther away, over 4,000 miles from the Colombian coast. The year was around 1150 AD. The genetic signal was clear. People from the Americas had mixed with the ancestors of those living on Fatu Hiva. Then, over the next 2 centuries, that DNA spread to other islands, north through the Marquesas, across the Tuamotus, and only later, by about 1380, to Easter Island. The timeline runs counter to every old theory. For decades, researchers assumed that if any contact happened, it would have started with the islands closest to South America. Instead, the earliest evidence appeared in one of the most remote corners of Polynesia. The distance involved is staggering. 4,000 miles of open ocean with no stepping stones, no land in between. This was not an accidental drift or a short hop. It was a journey that required skill, planning, and the ability to survive weeks at sea. The DNA didn't just rewrite the map of ancient contact, it forced a new question. How did anyone, centuries before European navigation, make such a crossing? The answer isn't in the genes alone. It's in the way Polynesians explored their world and the routes they chose to take. Polynesian navigators mastered the world's largest ocean long before European ships crossed the Atlantic. Their double-hulled canoes, built from lashed timber and woven sails, carried families, food, water, and plants for journeys that stretched weeks at sea. These were not simple rafts. They were engineered for speed, stability, and endurance. By 1000 AD, Polynesians had sailed over 2,400 miles of open water to settle Hawaii, using nothing but the stars, the sun, and the feel of ocean swells beneath their hulls. By 1300, they reached New Zealand, a voyage of more than 2,000 miles from their nearest homeland. They read the sky like a map, memorizing the rising and setting points of dozens of stars. They tracked the shapes of waves, the flight of birds, and the color of clouds on the horizon. Every journey was a test of knowledge passed down through chants and stories, not written charts. These skills made the Pacific less a barrier and more a network of possible routes. The distances that seem impossible today were routine for them. If any ancient people could cross 4,000 miles of open ocean, it was the Polynesians. Sweet potatoes grow across Polynesia, but their roots trace back to South America. Archaeologists have found sweet potato remains in Hawaiian soil dating to around 1000 AD, centuries before any European ships crossed the Pacific. In the Cook Islands and Mongariva, ancient tubers were unearthed in layers dating as far back as 990 AD. The plant itself cannot float across an ocean and survive. Its seeds spoil in salt water. The only way it could have arrived in the islands is if people carried it. But the story does not stop with the plant. The word for sweet potato in Quechua, spoken in the Andes, is kumara or kumal. In Maori, it is kumara. In Rapa Nui, it is kumara. Across the Pacific, the names echo each other. Linguists have tracked this connection for over 100 years. The match is too precise to be coincidence. The plant and the word travel together. This is more than a trade of crops. It is a record of a meeting, one that left traces in both language and agriculture. The DNA study confirmed what the sweet potato had hinted at all along. People crossed the Pacific, carrying more than just stories. They brought food, words, and a piece of their world to the other side. The question of who crossed, Polynesians or Native Americans, remains at heart of the debate. Some researchers argue that Polynesians with proven navigation skills set out eastward. They reached the coast of South America. Their history of long-distance voyages, from Hawaii to New Zealand, supports this theory. The timing also fits. Polynesian exploration peaked around 1200 AD. That is the same period the DNA mixing occurred. Others point to the possibility of South Americans making the journey west. Along the Pacific coast, people built large balsa wood rafts with cotton sails and centerboards. These vessels could carry tons of cargo and survive weeks at sea. In 1947, Norwegian explorer Thor Heyerdahl sailed the Kon-Tiki. It was a replica of a pre-Columbian raft. He traveled from Peru to the Tuamotu Islands. The distance was 4,300 miles. The voyage took just over 3 months. His journey proved that the winds and currents could carry a raft across the Pacific. The trip was slow and dangerous. However, the genetic evidence tells a one-sided story. Native American DNA appears in Polynesians, but not the other way around. That leans the argument toward Polynesians visiting the Americas. They may have taken crops, and perhaps people. Then they returned home. Still, the absence of clear proof leaves the mystery alive. The Pacific remains a sea of possibilities. Only the DNA serves as a silent witness to what happened. History books have long credited European explorers with linking the continents. They drew the first lines between distant worlds. DNA evidence from the 2020 study forces us to rethink that story. Centuries before Columbus, the Pacific was a route, not a barrier. It connected people across thousands of miles of open water. Native American DNA appears in Polynesians, but not the reverse. That breaks the pattern expected by old models. It suggests a journey, an encounter, and a return. A genetic legacy remains visible today. This finding does not just add a footnote to history, it reshapes the story itself. Civilizations once thought isolated were part of a larger network. Crops, language, and ancestry moved across the ocean. People whose names are lost left traces that endure. As Alexander Ioannidis said, "If you think about how history is told for this time period, it is almost always a story of European conquest, and you never really hear about everybody else." The Pacific crossing proves the world was more connected than we imagined. Many stories remain hidden, waiting for evidence to bring them to light. Today, genetic evidence leaves no doubt. The Pacific was a bridge, not a barrier. The real story of human connection is older, stranger, and more ambitious than textbooks admit. New DNA technologies emerge, and the boundaries of our shared past keep moving. The next discovery could rewrite everything again.